Hello, good morning. Can you hear me? Okay, good. So we're now on week 10. Am I correct? So week 10. So 2 weeks from now, you'll have your uh, midterm exam for week 10. So there are two topics that uh, are under it. So one would be the mixture problem, and then the other one is the electric circuits, so applications of electric circuits. So we'll try to see if we could have examples for electric circuits, but if we were not able to finish those things, so we just have the videos, okay, so which are uploaded on your modules. Okay, so for the uh, mixture problems are about solutions. Okay, so we are talking about solution on a certain container, so which is a mixture of a solute and dissolvent. So if you could recall in chemistry, so solute so would be the substance, okay, so which is dissolved on a certain liquid, so forming a solution. Mixture problem so involve a certain container, so which contains it could be initially it could be a mixture already, or initially it could be a pure solvent. And in mixture problem, so usually we have a certain fluid, so which enters in a certain container and then it goes out. So usually the one that we are getting here so would be the amount of the substance that would be present at any time, so within a given container. So for mixture problem, so usually uh, the relation that we are using here would be the amount, okay, so the amount of substance, okay, that substance could be the solute. Okay, so the amount of the substance at any time, or sorry, the rate of change. Okay, the rate of change. Yeah. The rate of change on the amount of substance at any time, so is directly proportional to the difference on uh, the amount of substance per unit volume, that is entering and leaving the container. So if we are to express this one into a differential equation, so let's say we're going to let A, or that would be dA all over dt, so is equal to CI QI minus C out Q out. So this is our differential equation. And then from here, so A here so would correspond to the amount of the substance. So usually that would be in terms of mass. So T is the time. So Ci is the input concentration. So Qi is the input flow rate, input volumetric flow rate. So C out is just the output concentration. And Q out is the output volumetric flow rate. So usually the amount of substance is a unit of mass. So the amount of substance is a unit of mass. So it could be in grams or it could be in kilograms. So that's just an example. So time could be in seconds, in minutes, or whatever would be the unit of time. So the input concentration or the concentration, so that would be the amount of the substance per unit volume, or that would be the mass per unit volume. So in those cases, so we could have a unit, let's say for example, as kilogram per minute, okay, or we could have a a gram, okay, so per second. So those are the concentration. So this would be the amount, okay, so this is the amount of the substance. Oh, sorry, it's time. That should be volume. So let's say it would be kilogram per liter, or it could be grams per milliliter. Okay, so those are the examples. So example nito, for example, we have a brine solution. Pag sinabi nating brine solution, so that is a solution of a combination of water and salt. Okay, so salt is dissolved in a water, so forming the brine solution. So pag sinabing what would be the concentration of the salt on the brine, so pwedeng sabihin natin na let's say we have 50 grams per 500 ml. So there would be 50 grams of salt. So for every 500 ml. So that would be the concentration. Okay, so that is the amount of the substance that is present on a certain liquid. Okay, so that is the concentration. So meron tayong concentration that is coming in, and then since that concentration will be mixed inside, okay. So if I'm going to draw it, so parang if I would have a container, so let's say I have a container, and then so with a certain uh, liquid. So usually meron siyang initial volume. Okay? So merong initial volume yung V sub O. So V sub O is the initial volume. Tapos meron din siyang X sub O. Okay? So X sub O, so yun naman yung initial amount. Okay? So that is the initial amount. So initial amount of the substance. So pwedeng initially there is 100 grams of salt. Okay, so dissolved on the liquid. So that is the X sub O. Pero pag sinabi niyang initially, there is a pure water inside the container. So pag pure water yan, so ibig sabihin, we don't have a solution. So it's just a water. So in those cases, initially, the amount of the substance that is present will be zero. Okay? So pero kapag sinabi nga, so we just have to write down, so that would be the initial amount of the substance. So ayun, on a certain solution, so usually ang solution natin, so pwedeng it's already a mixture between solute and a solvent, or pwedeng it's just a purely solvent. Okay? So, ganun lang yung sa loob ng container natin. But then, in mixture problem, so usually there is a certain fluid that comes inside the container. So, again, it depends. So, what would be the concentration, or sorry, so we usually have the concentration or the input concentration, whatever would that be. Pwedeng kung pure water, okay, again, yung concentration, so in short, that would be zero, yung CI natin. Pero if it is not pure, so meaning it's a mixture of a solute and solvent, so therefore we have a certain value for our concentration, okay, or the concentration of the fluid that enters the mixture. And then aside from that, so meron din tayong tinatawag na Q sub I. So Q sub I naman, so that is the input volumetric flow rate. So yung kanina we are talking about the amount of the substance per unit volume. So yung input flow rate naman, so we are talking about how fast, okay, so how fast the fluid enters, okay, so how fast the fluid enters a mixture or enters the mixture. So usually our unit there so would be volume per unit time. Okay, so input volumetric flow rate, so that would be volume per unit time. So pwede siyang in terms of liters so per minute, okay? Or pwede siyang in terms of milliliter, okay, so per second. So those are example of the input volumetric flow rate. So the flow rate, that is how fast the fluid enters. Okay, so how fast the fluid enters the mixture or the container. So ganun din dun sa output concentration. So ano yung amount of the substance that is present or that is coming out. Okay, so that is coming out from the given mixture. So the output volumetric flow rate, so gaano naman kabilis yung paglabas nung mixture. So we have C out as well, and then we have the Q out. So usually yung mga mixture problems natin, so involving first order differential equations, so are limited to this diagram. Okay, so we just have to determine so ano yung input concentration as well as the output. So together with the input and output volumetric flow rate, then we have to consider as well so what would be the initial volume of the liquid. So when we are talking about the initial volume, okay, so yung initial volume natin, we are talking about the mixture. We are not talking about the capacity of the container. Okay, so it's always the volume of the mixture. And then yung initial amount of the substance, as I mentioned a while ago, if it is a pure liquid, so our initial substance would be zero. However, if it is not, if it's already a mixture initially, okay, if it's already a mixture initially, so therefore there is a given initial amount of a certain substance, whatever would be that substance is. And aside from this formula, okay, so take note that the concentration, okay, so the concentration formula is always equal to the amount, okay, so that is present. So since ginamit natin yung A to be the amount, so gamitin ko na rin ang A. So A all over V. So wherein A is the amount of substance, so which is a unit of mass, and then divide it with the volume. So that would be the concentration formula. So yan ang concentration formula natin. Pero the volume naman, So the volume that is present, or the volume of the mixture at any instant of time, so can be computed as well. Or, sorry, the volume at any time. So the volume at any time is equal to the initial volume, so plus Q sub I minus Q sub out times the time. So kasi nga, the volume on uh, the volume of the mixture inside the container so varies. So depende on what would be our flow rate. So as you can see here, if the the flow rate, or the input flow rate and the output flow rate, so given that Qi is equals to Q out, so what happens? So if the flow rate that enters is the same as the flow rate of the liquid that goes out from the container, so we can see here that the volume of the container will be constant. So tama. So B would be equal to initial volume. So in that case, so constant yung volume natin noon, hindi siya gumagalaw kasi yung input rate natin at saka output rate natin would be the same. However, if this is not the same, so what would happen if the input flow rate is less than the output flow rate? So in the long run, so what would happen? What do you think? So nare-reduce yung volume. So at time infinity, so what happens to the volume? Zero. Okay, so tama, Earl. So ibig sabihin, so kapag mas mabilis yung paglabas, so there would be a tendency that in the long run, so the volume inside the tank so will be emptied, okay, or magiging zero. Mawawala lahat yon. However, what would happen if the input flow rate so is greater than that of the output flow rate? So input flow rate is greater than the output flow rate. So what would happen? So there is an increase in the volume that at time greater than infinity, so what would happen to the liquid inside the container? So at time infinity, so very good. So Earl, it will overflow. Okay, so kasi nga, yung capacity ng container natin is finite. Okay, so once it reaches the capacity of the container, so overflow will occur. Okay, so those are the uh, idea, okay, or those are the principle behind mixture problems. As you can see here, there is no working equation right away, unlike with that of the growth and decay as well as the Newton's law of cooling. So kagad meron na tayong formula doon, no? Pero on this one, wala tayong exact working formula. So what we have is the differential equation. And this time around, we really need to do the methods of integration. So for us to resolve problems for mixture. Okay, so to better understand this again, so let's have our first example. Di ba? Ang dami. Sa baba na lang. Okay, so we have question number one. It is loaded already. A large tank is filled to capacity, so with 2,000 liter of pure water. Brine containing 0.25 kilograms of salt per liter is pumped into the tank at a rate of 20 liters per minute. The well mixed solution is pumped out at the same rate. So first, we have to find the number of kilograms of salt in the tank at time t. Second, what is the concentration C of t of the salt in the tank at time t and at the time of 5 minutes? What is the concentration as well of the salt in the tank after a long time? So where in t would be infinity. Fourth, at what time is the concentration of the salt in the tank equal to one half the limiting value of question C? And lastly, so under the assumption that the solution is pumped out at a faster rate of 40 liters per minute, and then when is the tank empty? Okay, so ang dami yan, di ba? So, but we have to visualize this. So by drawing a certain tank, okay, or a container, so sabi niya, it is filled. The tank, so una, so at large tank is filled to capacity with 2,000 liters. Although sabi niya, puno, no? Filled. O no, nag-pour in lang siya. So, the capacity is 2,000 liters. So, yung initial volume natin would be 2,000 liters. Pangalawa, brine containing 0.25 kilograms of salt per liter is pumped into the tank. So what is 0.25 kilograms of salt per liter? So brine containing 0.25 kilograms of salt per liter is pumped into the tank. So a certain a brine is pumped into the tank. Naglag. Ayan. So meron tayong 0.25 kilograms of salt per liter. What is that? Point 25 kilograms per liter. That is the input concentration. So that is the amount of salt that is present on the brine. So for every liters, merong 1/4 kilogram of salt. Dami nun, no? Tapos, it is pumped into the tank at the rate of 20 liters per minute. So pumapasok at 20 liters per minute. So ang labas niya, uh, at the, okay, the well mixed solution is pumped out at the same rate. So ibig sabihin, ang Q out natin is the same at 20 liters per minute. So hindi niya binigay yung output concentration natin, no? And then, so what is the initial amount of substance based from the problem? So 0, no? Kasi nga, it is a pure water. So therefore, the initial amount of salt, okay, so is 0. So this is how we are going to picture the problem. So that would be our given. So hindi ko na isulat yung required. So I'll right away draw with our solution. So tanong muna yung A. So sabi niya, so find the number 80 of kilograms of salt in the tank at time t. So what would be the amount of salt at time t? So yung formula natin kanina, uh, dA all over dt is equals to CI QI minus C out Q out. So ngayon, so dA all over dt is equals to CI is point, ano lang dito again consistency of the unit. So hindi ko na isusulat yung unit pero pare-pares naman sila, no? So liters per minute for our output and input flow rate. And then for our concentration, it is kilogram per liter. So there's no need to convert. Input concentration is 0.25. And then our input flow rate is 20 liters per minute. And then minus C out is not given, so Q out is 20. So giving us dA all over dt. So 20 divides 4, so we have 5 minus 20 C sub O. The output concentration is not given. However, the concentration, so yung kanina, ano yung concentration natin? Ito, di ba? So that is the amount of the substance per unit volume. So therefore, C out is V or it's A all over V. But again, the volume at any instant of time is initial volume plus Q sub I minus Q sub O times T. Okay, so ang initial volume natin is 2,000 liters. So 2,000 plus ang QI natin is 20 minus 20 as well. So therefore, so since parehas yung input flow rate at saka output flow rate natin, so V is just equal to the initial volume, so which is 2,000. So therefore, the output concentration then so would be the amount of the substance uh, at the output, okay, or when the mixture, okay, so goes out from the tank, and then V would be equal to 2,000. So giving us, so substituting that, so dA all over dt then would be equal to 5 minus 20, and then ang C out natin is A all over 2,000. Or dA all over dt would be equal to 5 minus A all over, or sorry, 100. So dA over dt is equals to 5 minus A all over 100. So this time around, we already have our differential equation. So once you were able to formulate our differential equation, so this is the time to solve it using methods of first order differential equation. So what kind of first order differential equation is this? Huh? So what kind of first order differential equation is this? Yung dA over dt is equals to 5 minus A all over 100. So how do we resolve that? What method? Exact? Yung mas madali. It's already on the standard form. dA all over dt plus 1 over 100 times A is equals to 5. Separable, linear. Okay, so it's a linear equation. So mixture problems, so all of them are linear equations. Okay? As far as I can recall. So hindi siya linear Bernoulli. Pero all of them, most of the time, are linear. Okay? So in this case, so we have now our P of t, so which is 1 over 100. And then ang Q of t natin would be 5. So ano kasi yung formula natin for our integrating factor? So mu of t would be e raised to the integral of P of t dt. Tapos e would be equal to P of t is 1 over 100 dt. Or this would just be simply e raised to t all over 100. So that would be our integrating factor. So tapos ang formula natin, mu of t times, so saan siya linear? Linear siya sa a. So a is equals to the integral of q of t, mu of t, dt. So mu of t is e raised to t all over 100. So multiplied it with a is equals to q of t is 5. And then mu of t is e raised to t all over 100 dt. Or maya na yung plus c. So ngayon, so to integrate this, so ang u natin would be t all over 100. So ang du natin would be dt all over 100. So ngayon, so ang neutralizing factor natin yan, so would be 1 over 100 or just simply 100. Tama? So the inverse of 1 over 100 would be 100. So we just have then, so E t over 100, so times A would be equal to, so 5 times our neutralizing factor of 100, and then E raised to t over 100 plus C. Or E raised to t all over 100 times A is equals to 500 E raised to t over 100 plus C. Then multiplying everything by e raised to negative t over 100. So that would be a is equals to 500 plus c e raised to negative t all over 100. So this would be our general formula. However, we still have c. Okay, so we need to find what would be the value of c. So when time is equals to 0, so what's the value of a? So when t is equals to 0, what is the value of a? 500. Remember, A is the amount of salt that is initially present on our mixture. Oh, ayun pala. So, mali ginamit kong ano, sorry. So, this should be A sub O. So it is 0. So remember, di ba, it's a pure water. So initially, walang laman, okay? Or walang salt that is present on the mixture. So therefore, yung A natin, A sub O, so would be equal to 0 as well. So from here, so we'll have 0 is equals to 500. So plus C e raised to negative 0 over 100. So this is 1. So therefore, C is equals to negative 500. So in short, the amount of present or the amount of salt that is present on our mixture at any instant of time would be equal to 500 minus 500 e raised to negative t all over 100. So yun yung sagot natin for question A. So what is the amount of the substance at any instant time t? Question. Wala. So let's proceed with letter B. Sabi niya daw, so what is the concentration of the salt in the tank at time t? So at the same time, so what will be the concentration after 5 minutes? Okay, so after 5 minutes. So for letter B, so ano daw yung concentration? Okay, so when at time t, so yung pangalawa naman, ano yung concentration when time is after 5 minutes? Tama ba? After 5 minutes. So how do we get this? And yung C of T natin, di ba, the concentration formula is the amount at any time. So divide it with the volume at any time as well. So kaya lang again, so the amount at any time or the volume at any time is the initial volume plus Qi minus Q out times T. So ngayon, the concentration at any time T would just be, ano yung A of T natin? Ito yon. So which is our answer before. So that is 500 minus 500 e raised to negative t all over 100. Tapos, divide it with initial volume is 2,000. So plus, yung kanina, 20 minus 20 times t. Or in short, so this would just be 0. Or C of t then. So factor out ko si 500. So that would be 500 times 1 minus e raised to negative t all over 100 divided with 2,000. Or just simply C over t, so would be 1 minus e raised to 1 minus e raised to negative t all over 100 divided with 4. Tapos when time is equals to 5, so what would be our concentration? So the concentration then, so would be equal to, so 1 minus e raised to negative 5 over 100 divided with 4. So what is this one? So the concentration, so tama, gawin ko yung siyang 4 decimal places, 0.0122, no? So 0.0122, and then the unit will be kilogram per liter. Tama ba? Our concentration so would be kilogram per liter. So let's have letter C. So going back to our problem, letter C. So what is the concentration of the salt in the tank? So after a long time. So that is when T is infinity. So when T is infinity, so what would be the concentration? C then would be equal to 1 minus e raised to negative infinity over 100 divided with 4. What is C? So ano yung mangyayari dun sa concentration niya? That is 0.25 kilograms per liter. So what can you see here? So what is the 0.25 kilograms per liter? Where is it equal? It is equal to the given or yung input concentration natin, no? So kumbaga, initially we have a pure water. Tapos may pumapasok na actually the fluid, it's already a mixture na meron siyang concentration of salt. So in the long run, okay, so in the long run, so we could have a concentration which would just be equal to the input concentration. So will it be possible to have a concentration within the mixture which is greater than the concentration of the input mixture? So pwede ba yung mangyari yon? Will there be a time na yung concentration ng salt within the mixture will be greater than the input concentration? So hindi, di ba? So hindi pwedeng mangyari 'yon. So yung maximum concentration within the mixture is just up to the concentration of the input of our input mixture or our input fluid. Okay? So kasi saan manggagaling yung concentration na 'yon? So kumbaga parang magpaparehas na lang sila in the long run. Parehas na yung concentration nung pumapasok at saka yung within the mixture itself. Then meron siyang letter D naman. So at what time is the concentration of the salt in the tank equal to 1/2 the limiting value of question C? So at what time is the concentration of the salt in the tank equal to 1/2 the limiting value? In short, yung final concentration natin when T is equals to infinity, so that would be our limiting concentration. So kailan natin ma-attain yon? If the concentration is half. So what would be the time Okay, so what would be the time when our concentration is equals to half of the concentration when the time is infinity. So ang C natin yan, so would be, so 0.25, so divided with 2, so C would be 0.125 kilograms per liter. And then we have C is equals to 1 minus e raised to negative t all over 100 divided with 4. So 4C then would be equal to 1 minus e raised to negative t all over 100. So baliktarin ko sila. So e raised to negative t all over 100 would be equal to 1 minus 4C. Tapos take the logarithm of both sides. So ln e negative t all over 100 equals to ln 1 minus 4C. So e, so negative t all over 100, so would be equal to ln of 1 minus 4C. Or t is just negative 100, so ln of 1 minus 4C. So t then would be equal to negative 100, so ln of 1 minus 4 RC is 0.125. So 69.3031. And the unit will be minutes. Kalimutan ko yung mga unit. Minutes, no? Okay, so kalahati nung initial concentration so will be achieved after 69.31 minutes. Tama. And lastly, so under the assumption that the solution is pumped out at a faster rate of 40 liters per minute, when is the tank empty? So what do you suggest on how to solve this one? So pinalitan daw. So yung Q out mo ngayon, so naging 40, oh sorry, 40 liters. So yung Q in mo, it's still the same. So 20 liters per minute. So kailan mawawalan ng laman yung tangke? So what formula are we going to use? So do I need to use yung original differential equation natin? Ayan. So very good. So we already have our formula, no? So yung V is equals to initial volume, so plus QI minus Q out times T. So V minus initial volume equals to QI minus Q out times T. So therefore, T is equals to V minus initial volume, then QI minus Q out. What is V? Kasi ang initial volume natin is 2,000, di ba? Because QI is 20, Q out is 40. So V is 0. So bakit siya 0? Kasi that is the time that it will be emptied. So wala nang laman. So ang volume mo, 0, na wipe out. So T then would be negative 2,000 over negative 20. So that is 100. Or in short, that would be after 100 minutes, okay, at that flow rate of 20 liters per minute, and then 40 liters per minute for our output flow rate. So we will arrive to this time of 100 minutes. So that ends our first problem. Question? So nagigets natin yung idea. Medyo mahaba rin to, no? So mahaba to kasi nagdi-derive tayo ng formula, no? So if there are no questions, let us proceed with another example. So a large tank is partially filled with 400 liters of fluid, in which 5 kilograms of salt is dissolved. So brine containing 0.25 kilograms of salt per liter is pumped into the tank at a rate of 20 liters per minute. So the well mixed solution is then pumped out at a slower rate of 15 liters per minute. So find the number of kilograms of salt in the tank after 30 minutes. The second one, if the capacity of the tank is 500 liters, so when will the tank overflow? And then what will be the number of kilogram of salt in the tank at the instant it overflows? So again, so let us draw our figure. So by the way, usually on the problem, so it says here that it is usually well mixed. Kasi our assumption here that the salt or whatever would be that substance is equally, okay, dissolved on all parts of the mixture. Okay, so ibig sabihin pare-parehas yung concentration at different parts of the volume of the mixture. Kasi pwedeng baka yung substance natin mag-settle down dun sa baba. So definitely hindi there is already a change on the concentration, no? Pero ang assumption natin lagi dito, it is a well-mixed mixture. So for our problem, so it is partially filled. So meron siyang initial volume, so which is 400 liters. Tapos this time around, hindi siya pure. So meron siyang, the fluid contains a 5 kilograms of salt. So ibig sabihin, yung amount ng salt natin initially would be 5 kilograms. Tapos, a brine is entering. So meron tayong input concentration of 0.25 kilograms per liter. Tapos it's pumped in at 20 liters per minute. This time around, so it is pumped out at a smaller or a at a uh, slower rate, so which is 15 liters per minute. So that would be our given. So yung unang hanap natin, so find the number of kilograms of salt in the tank after 30 minutes. So the amount of salt in the tank at 30 after 30 minutes. Okay, so hopefully may laman pa to. Ay no, meron. Hindi pa sana siya nag-overflow, no? After 30 minutes. Anyway, so let's try to solve the problem. So we're going to use the same formula. So dA all over dt is equals to Ci Qi minus C out Q out. So dA all over dt. So Ci is 0.25. Then Qi is 20 minus C out. Q out is 15. Or dA all over dt equals to 5 minus 15 C out. So C out is A all over V, or A all over initial plus Qi minus Q out times T. So A all over, so initial, V initial, V initial, 400. So plus yung initial concentration natin, or sorry, the initial flow rate, so 20. Tapos yung output flow rate natin is 15. Then multiply it with T. So C out then would be A all over 400 plus 5T. So dA all over dt then would be equal to 5 minus 15A all over 400 plus 5T. So kung i-simplify natin yon, dA over dt, 5 minus, so we could factor out 5, no? So that would be, then that would cancel out. So matitira would be 3A all over 40, is it 80 plus T. Okay? So now we have our equation to be dA all over dt. So plus 3 all over 80 plus T times A is equals to 5. So ang P of T natin yan, so will be 3 over 80 plus T. And then ang Q of T natin, so would be 5. So mu of T, so would be equal to E raised to, so labas ko na yung 3. And then dt all over 80 plus T. Or simply E raised to 3 dt over 80 plus T is ln. So ln of 80 plus T, or E raised to ln of 80 plus T raised to 3, or simply 80 plus T raised to 3. So now that we have our integrating factor, so mu of T, so times A, would be equal to Q of T, mu of T, dt. So mu of T natin is 80 plus T raised to 3 times A equals to the integral of 5, 80 plus T times 3 dt. Or it would just be, So 80 plus t raised to 3 times a, and that would be 5. So power formula, that would just be 80 plus t raised to 3 plus 1 is 4 all over 4. Then plus c. Or we could have, or we could divide everything by 80 plus t raised to negative 3. So a then would be equal to 5 over 4. So 80 plus t, then plus c times 80 plus t raised to negative 3. So that is our amount at any instant time, but we have seen. So this time around, so when t is equals to 0, so what is a? So hindi siya 0, di ba? So going back, so meron tayong amount, which is 5 kilograms. So we're just going to have that one as 5. So when t is equals to 0. So a is 5. Is equals to 5 over 4. So 80, t is 0. So that would just be 80. Then plus c. So 80 raised to negative 3. What is c? That's the value of c. To 20. 80 times 5 divides 4. So 5 minus 100 is 95. Parang hindi 20. Medyo malaki. Is, could you double check it ha? So nakukuha ko is negative 4, 864, or sorry. Negative 48.64 times 10 raised to 6. Negative 48.64. Tama, negative 48. No? So A then would be equal to 5 over 4. So 80 plus T minus 48.64 times 10 raised to 6. And 80 plus T raised to negative 3. So ngayon, after 30 minutes, so what is A? So when T is 30, so what is A? So A then, so would be 5 over 4. So 80 plus 30 is 110. Minus 48.64 times 10 raised to the 6. And then 110 raised to negative 3. 100.96 kilogram. Tama? So, kilogram. Dami. Dalawa sa ako. Sabagay, yung malaking container, no? So, that is 500 liters. So, 100.96 kilograms of salt is present after 30 minutes. So, next question. If the capacity of the tank is 500 liters, so when will the tank overflows? So, ito, kamukha lang nung kanina. So, ang T natin would be the capacity. So, ano daw yung time? So, when the volume or when it overflows. So, yung volume natin is 500 liters. So, T then would just be V minus V out or V minus initial volume over Q sub I minus Q sub out. So, which is 500 minus 400. And then, ang Q sub I natin is 20. So, minus 15. So, 100 divides 5. So, we have 20 minutes. So, after 20 minutes, that is the time that it will overflow. No? And lastly, so what will be the number of kilogram of salt in the tank at the instant it overflows? So dapat yung amount of salt is less than 100. No? So what would be the amount? So at the time of the overflows. So in short, 20 is 20. So A then would be equal to 5 over 4. Tapos we have 80 plus T, no? So, sulat ko, 80 plus 20, and then minus 48.64. 80 plus 20, negative 3. So, what is 8? $76.36. So we have 76.36. So for the amount of salt after 20 minutes. So tama, no? Mas konti as compared dun sa 30 minutes. 76.36. Okay? So those are examples of mixture problem. Do you have questions? Clarifications. So we're done with mixture. If you want additional examples, so we have three more on our module. So merong tatlo. Sir, pasend po ng mga examples. Send ko na. Tapos yung electric circuits, actually formula lang sila eh. Di ba ang bagal ng internet? Ayun, send din. Sige, we will not solve, pero sige, introduce ko yung topic ng ng electric circuits. Mayroon tayong examples doon sa presentation, pag-ipanood na lang yon. Pero yung discussion niya, so para magka-idea lang tayo. Out of the circuits kasi, uh, yung electric circuit, so which resembles a first order differential equation, would be the RC and the LC circuit. So RL and RC circuits. So a combination of the others, so higher order na siya. Okay? So sa first order, dalawa lang. RL circuit at saka, actually series RL circuit at saka series RC circuit. So palitan mo yung combination niyan, gawin mong parallel, okay? Or gamitin mong RLC or other circuits, magpo-form siya ng higher order. Kaya simple lang yung sa electric circuits. So for example, for this series circuits, ang voltage across a resistor is just simply the voltage multiplied with the resistance multiplied with the current I. So as simple as the Ohm's law. Pero yung voltage natin across an inductor, so that would be the inductance L. So multiply it with the derivative of I with respect to T. So that is the change of the current with respect to time. So multiply it with the inductance. So we'll be able to determine the voltage developed across the inductor. So again, so para makuha natin yung voltage or para ma-analyze natin to using differential equation, so we could just use KVL. So magki-KVL tayo, that would be the sum of the voltage across the resistor and the inductor, so would be equal to the voltage of our source. Or in short, Ri plus L times di over dt is equals to V. So in short, we would have a linear differential equation. So ito, so meron tayong linear differential equation for our series LC circuit or series RL circuit. So kukunin natin yung current at any time. So we could solve this one using first order differential equation or linear differential equation. Pero kung pinapakuha yung voltage across the resistor or voltage across the inductor, so kunin mo muna yung I. So pag nakuha mo na yung I, multiply mo lang sa R, so you'll get the voltage across the resistor. Kung voltage naman on the inductor, so you need to find the di all over dt first. Then multiply it with the inductance. Yung RC naman, ganun din. So ang difference niya, ito ang formula niya for our voltage across the capacitor. So that is 1 all over C, multiply it with the integral of I dt. So we're in kung magki-KVL tayo, so the voltage, so this is the voltage on the resistor, plus voltage on the capacitor would be the voltage of the hour or the supply voltage. And then, pwede nating kunin, for example, in terms of charge. Kasi we want to determine what would be the charge across the capacitor. So remember, meron tayong formula na ang current, okay, at any instant is equal to the dq over dt, di ba? Current is the change or the flow of charges. The flow of charges is actually the current. So therefore, I is equals to dq over dt. So kung magsiseparable equation tayo, I dt is equals to dq. So integrate mo siya both sides. So magkakaroon ka ng integral ng dq would be q times the integral of I dt. So ngayon, kung i-substitute mo to, so this one, the integral of I dt, that is q. So magkakaroon tayo ng r. Ang I natin is dq all over dt. So plus 1 over c times q is equals to b. So ito in terms of current, ang formula na to, ito naman in terms of charge. So kung in terms of charge, so that is r dq over dt plus 1 all over c times the charge q is equals to v. So ngayon, kung gusto mo naman kunin in terms of current, so going back to the current, so derive mo ulit yon, magkakaroon ka ng r di over dt, so plus I all over c is equals to 0. So ito yung general formula natin. Okay? So in finding the charge across a capacitor, or if we want to determine the current naman that is flowing through the circuit, so ito naman yung formula natin. So usually hindi natin ginagamit yung sa taas, no? Or this one. Okay, so para maintindihan natin yan, so you need to view the video. Okay, so on Thursday, so you can view that video for the mixture problem. Oh, sorry, for the electric circuits problem. So that's all for week 10. Ang quiz natin, so will be next week. We'll meet again on Tuesday next week. So we'll be discussing the final topic for the midterms, so which is the introduction to higher order differential equation. So together with solution of homogeneous equation. So yun yung i-discuss natin on Thursday. Or sorry, on Tuesday next week. Tapos, ang quiz natin will be Thursday next week. Ang quiz natin will be a long quiz, no? So our quiz will be a long quiz. It's ano na siya, minsanan na siya. So siya yung magiging quiz 3 and quiz 4 nyo. So 1 day. 2 days. O sige, hanggang Saturday. So I'll activate it on Thursday during your time. So mag-end siya ng Thursday, Friday, Saturday. So it will be worth 200 points. bago yung gagawin natin, ha. So, ang gagawin ko would be parang kamukha ng mga activities nyo this time. So, right away, you'll be able to know whether your answer is correct or not. Kaya lang mag-iiba-ibang set na kayo. So, I am already uploading yung mga questions. So, iba-iba na yung questions nyo. Uh, and then, you're going to enter. So, ang exam would be multiple choice and uh, inputting the numerical answer. Tapos, of course, you have to submit as well the solution. No? Pero ang exam nyo more on kamukha nung recent activities. Yung activity H and activity I. Tama ba? A, B, C, D, E, F, G. H and I. So activity H and I. So more on, ganun yung quiz nyo. No? So yung unang set, okay, or first part of the exam, it's all about theory. Okay? So more on the process, more on the method. Para yung mga common question ko sa inyo. Like for example, kanina, uh, will it be possible, let's say true or false, will it be possible na we'll have a concentration greater than the input concentration? So, parang ganun. So it's more on the process. So yung first part. Tapos yung second part would be the problem solving. So first part is multiple choice. Second part would be problem solving. You're just going to enter your final answer. Okay? Or depending on the question. So you have, sige, 2 days to do it. Questions? So kung wala na, so we'll meet again on Thursday or Tuesday next week. Okay, so for our last topics for the midterms. Okay, thank you. Thank you very much. Thank you.